Hi, and welcome to this video snippet on neuromeningeal tests. This will be an overview of the test themselves and not any specific tests. Each one will be covered in detail during the course module. So the straight leg raise, prone flexion for the lumbar spine, for example, neurodynamic tests, so-called, for the cervical spine. But this will be an overview looking at principles and some of the purposes of what we're doing. So these neuromeningeal tests are an example of the constant length phenomenon. And basically what the constant length phenomenon says is that the range of motion of one joint is dependent on the position of another joint over which a common tissue runs. So if we look at this, we'll say this is straight leg raise. If you see we're doing hip flexion with the knee extended, then you'll get a certain range of motion at the hip. If we now flex the knee, then the hip range of flexion will increase. This is fairly obvious, but it's worth stating exactly what this is. So this is a constant length phenomenon, and this is the principle behind neuromeningeal testing. And it's important that you understand it fully. Otherwise, you'll do a straight leg raise, you'll get back pain, and you'll say, oh, it's dural. And that's not necessarily true at all. You have to manipulate this constant length phenomenon to be sure of what the test result is telling you. So the tests include neck flexion, scapular retraction, upper limb neurodynamic tests, slump tests, straight leg raise, prone knee flexion. Now, all of these tests tend to move the neural tissues and the dural tissues, the dural sleeves, with the test. The neck is a little different in that the dura is actually tethered to the transverse process where it exits the canal. So the dura really can't move terribly well except at the lowest level. So you're now moving the neura in and out of the dura, which is static. So that one is a neural mobility test. The rest of these are neurodural mobility tests. So we look at sensitizations. The purpose of these is to improve the sensitivity of the test and also to probably specifically test certain parts of the neuromeningeal tissues. The best example of this are the upper limb tension tests. So there's a basic position for the upper limb tension test, which is contralateral side flexion and abduction, sorry, give me left arm, an abduction of the arm. After that, you can then move the elbow into flexion or extension and the wrist into flexion or extension. And each of those maneuvers stretches or moves a component of this whole neural extension into the arm. So, for example, if I basically flex the wrist and flex the elbow, I'll be stretching the radial component. If I extend the elbow and extend the wrist, then I'll be extending the medial component. And if I flex the elbow and extend the wrist, it'll be the ulnar component. So these improve sensitivity because probably side bending and abduction isn't going to be a problem, isn't going to be a symptomatic success. So it improves sensitivity, and to a certain extent, it improves specificity, at least the tissue that you are specifically trying to test. It also confirms the constant length phenomenon. As I said, this is important. If I do a straight leg raise, and let's say I've got a sacroiliitis, traumatic or systemic, doesn't really matter, but I have a traumatic sacroiliitis, this can be extremely painful. And as soon as you start to move the sacroiliac joint with a straight leg raise, it becomes painful, and the straight leg raise will be limited. It'll be limited very low down. So this could easily be mistaken for a positive straight leg raise when the straight leg raise is supposedly testing the neuromeninges. But in fact, what you've got is a false positive for the neuromeninges, and you can confirm that quite easily by bending the knee. Now, if you bend the knee and then try to flex the hip, you won't get any more or much more movement at the hip, and the pain will increase. As any increase in movement you do makes it worse. So this will demonstrate that it's not a constant length phenomenon, and that it is actually you moving the hip, the sacroiliac joint, and possibly the lumbar spine. So this is the other purpose why you do these sensitizations, to prove that it is a neuromeningeal positive. The tests include neck flexion, which actually is a sensitization for all of the other tests. If I flex the neck, it pulls the dura and the neura upwards. So this will tend to stretch everything up, or at least shift it up. And if it can't move, then it will be stretched and painful. We can do neck flexion with scapular retraction, and we can do neck flexion with slump test. Elbow and wrist position, as I've just talked to you about. Slump with leg position. We do a slump without using the legs, which is useful, more useful for the thoracic spine, and it doesn't include anything lower. But again, you might even need leg position for this, just to increase the stress. But we can use leg position deliberately with a slump test for the lower levels, L4 and down. Straight leg raise, neck flexion again, ankle dorsiflexion, prone knee flexion with neck flexion, and also you can use slump. Now these are rarely done with prone knee flexion, but there's no reason why you can't do it. And if you think it's awkward, do the prone knee flexion in side lying and not in prone. It's not that difficult. It's rarely done, and there's every reason to do it. As many reasons to do it for prone knee flexion as there is for the straight leg raise. So don't be frightened to do this. So results for these neuromeningeal tests. You can get somatic pain. Now, somatic pain cannot be produced by the neural tissues. So we know that this is a somatic tissue, most probably the dura, the dural sleeve. But don't forget, we can also get, it's not just the sleeve. Meningitis will be extremely positive, particularly bacterial meningitis, will be extremely positive to the straight leg raise, as well as to neck flexion. So it's not just a neural sleeve, but we can say it's not a neurological tissue. We can get neuropathic pain, and now we can say that this is a neurological tissue causing these symptoms. Similarly with paresthesia. And we can get a mix. We can get compression of the dura by lumbar disc, for example. That has also damaged the nerve. So when we do a straight leg raise, we get both somatic and neuropathic pain. And even without damage to the nerve, we can get paresthesia with the straight leg raise, which isn't necessarily damage to the nerve, but just compression. And finally, we look at range of motion, which should be limited, and of course spasm, limiting that range. There's got to be evidence that this is not locally sourced pain, and we do this with sensitizations and the use and the interpretation of neuropathic symptoms. So the conditions that will test positive for this include neuropathy, radiculopathy, myelopathy. I forgot to put it on here, but meningitis, Multi-Crush syndromes, where we start seeing, say, evidence of ulnar nerve or median carpal tunnel syndrome, for example. And if we now apply the sensitizations for the median nerve, this may actually produce more tingling, or it may produce tingling where no other test does. And this might suggest that this is a multi-crush syndrome. Multiple sclerosis tests positive for this, arnold-Chiari malformations, diabetes, and adhesions on the neura or the dura. So I hope this snippet was useful to you and gives you a decent overview. Now, as I say, we'll be talking a lot more about these tests in the modules and in the Zoom sessions leading up to it. So I hope it's valuable, and I will talk to you soon. Take care, everybody. Bye-bye.